Welcome back. So we're here again with Mrs. Donahue and learning about scientific notation today. Now, just so you guys know, when we come back on Friday, we will be having an A day. So we'll have our class again. So please bring questions. Bring the completed homework assignments. So you should have like 3 different homework assignments to show me next time we're together. So hopefully you'll have all those done. And remember, after you're done with this assignment, you should be going online to do the quiz. So please do that as well. So make sure you get those 2 things taken care of. So our homework or our warm-up here is asking us just to review our exponent rules. So 5 times 2, multiply that to get 10. Then I can add the exponents, and 4 plus a negative 3 is 1. So that'll be x to the first. And you can just write that as 10x. Or you could have also thought about it as x to the 4th over x to the 3rd. And again, there's more x's on the top than the bottom, it'd be 1. Now this one, when we look at this, is a negative exponent. So we're gonna move its position in the fraction. So it's gonna move to the bottom and become positive. Now 10 to the 3rd is 10 times 10 times 10, which is 1,000. So this number, 10 to the negative 3, is not a negative number. It's a really, really small decimal. So it's like less than a penny, a really small amount. So we're going to talk about scientific notation today, which is a way to express really small numbers. And obviously it's called scientific notation because we use it a lot in science classes or in like kind of scientific problems. So scientific notation is written as a times 10 to the n power. Now we do use an x for the times symbol. It's the only time in algebra I really like to use an x for the times symbol. The biggest thing to know though, that a has to be a number in between 1 and 10. So a is in between 1 and 10. So I always say it's like a 1-digit number. A lot of times I call it like lunch money. So like, would it be a good amount to bring for lunch? Or like for a snack? And then the n tells us how big or small the number is depending on the type of exponent it is. So we'll talk about that. It's telling us how many times to multiply or divide by n, or by 10. Then standard notation is the way we normally write a number with just like all the zeros. So the normal way to write a number. So with all the zeros or decimal points. So 6.9 times 10 to the 5th is telling me to multiply by 10 5 times. So I'm going to multiply by 10, and if you know when you multiply by 10, it moves the decimal place over. So we're going to move the decimal place over 5 times. So I have 6.49. I'm going to move this over 5 times, and I'm making the number bigger because it's multiplying by 10. So this ends up being 649,000, so a very large number. So what we see is with a positive exponent, it's like multiplying by 10. Repeatedly. So it's a very large number. So it gets bigger and bigger and bigger. So a negative exponent, like we learned up here, is really like dividing by 10. So when we have a negative number, it's like dividing by 10 repeatedly. So when we do that, it becomes a really small number. So it's dividing by 4, and I'm going to move it 4 times, so 4 times smaller. So this moved 5 times because of this 5th power. This is going to move 4 times, but it's going to get smaller. So it's 1.19, but it's going to go 1, 2, 3, 4. So there's my very small number. So it got smaller and smaller. So the n back from up here, the n tells us How many times to move the decimal? So how many times to move the decimal point? So positive number, really large number, negative exponent, really small number. So again, pause is needed. If you guys need to pause it all to take notes. I did post the notes online, blank notes, otherwise you could just put these in loose leaf. So we're gonna write these numbers in scientific notation. So we have a really large number, a really small number. Again, that kind of hopefully will relate back to this. But remember, I want the first value to be a number in between 1 and 10. So right now I have 46, is this trillion? No, billion, sorry. So in order to make that a number in between 1 and 10, I want it to be 4.62. Because $4.62 is a number in between 1 and 10. So I have to see how many times I have to move my decimal. So it's back here right now. It's 3, 6, 9, 10 times. Now the 10 is always there, so the first 10 is always going to be a 10. But how many times I had to move the decimal is 10 different times. And it's a positive exponent because this is a really large number. So 6.2 times 10 to the 10th. Now this next one, again, I want the number in between 1 and 10. And right now it's a really tiny number, so I'm going to put it in between the 8 and the 5. So 8.5, $8.50 would make sense to take that as like lunch money. But now I have to figure out how many times I have to move my decimal. So 1, 2, 3, 4, 5, 6 times. But the 6, since it's a really small number, has to be negative because it's a small number. So the difference between these two is pretty clear. This is a really large number, this is a really small number. So now we're going to talk about multiplying with scientific notation. So just to make it clear, this is considered scientific notation, this is considered standard notation. So we want it in scientific notation versus standard. Standard's the way we normally write numbers. So with multiplying here, I'm going to have 3.5 times 2. 3.5 times 2. So I'm going to multiply those coefficients. So 3.5 times 2 is 7. Times, now I have these exponents. I'm multiplying them. If you guys recall, we add the exponents. So I'm going to add those exponents. So times 10, 4 and 5 would be the 9th power. And this is in scientific notation because 7 is a number in between 1 and 10, and then this is a very large number. Now you're going to watch me do some math by hand. I forgot to bring my calculator over here and I don't want to move, so I'm just going to stay where I am. But I need to multiply these two. So again, 7.8 times 3.2. Doing some quick math here, hopefully. I hope that's right. Something like that. So 24.96 times 10. And again, I'm going to add the exponents. So 5 plus a negative 2 would be 3. So 10 to the 3rd. But we have an issue. 24.96 is bigger than 10. So I can't leave it that way. So I need to make it smaller. So this number is going to get smaller by 1 decimal place. If that gets smaller by 1, this one's going to get bigger by 1. It's like a balance. Sorry. So this is getting bigger by 1, so 10 to the 4th. All right, I'm going to pause the video right there because if the video is more than 10 minutes, it's hard to upload. So I'm going to pause that there and I'm going to flip to the other side of the note. So this is part 1 ending.